Hello everyone, my name is Jack, and I'm presenting with my partner Danny. We'll be discussing about the voice input systems on object-oriented programming. So, what is the problem we're trying to solve? As we all know that object-oriented programming languages are widely used by programmers, such as C#, Java, etc. Most of these languages are quite powerful and have many supportive IDEs. Although supported by IDEs, there are still lots of repeatable coding workload for programmers, not only for beginners, but also for experienced programmers. After designing a suitable algorithm, most of the time, programmers have to type similar coding statements again and again, which make them feel boring and get tired soon. In daily working, programmers have to keep typing for hours, which brings potential risk to their hands. Is there any ways that we can rescue programmers' hands from traditional keyboard input programming and make them feel more relaxed? So, with this idea, we try to find out an input method that can replace traditional keyboard input in programming. Why not use voice input in programming? So here comes the research question. To what extent can traditional keyboard input replaced by voice input in C# programming to assist experienced programmers in reducing repeated coding workload in large-scale software development? We distinct our target group to experienced programmer, as we assume they have deep understanding of programming language, so programming for them becoming more mechanical. Also, we distinct our language to C#, as it is a popular OOP language with an extremely powerful IDE, which is Visual Studio. Now I'm handing over to Danny to talk about our research method.
To help us answer our question, we'll pick 3 C# experts to identify 5 basic coding constructs they think will most easily translate to voice input. The voice plugin will be applied to a commonly used integrated development environment to implement these 5 constructs. Then, we will give a software specification to 6 developers. 3 will use traditional keyboard and mouse input as a control arm, while the other 3 in the intervention arm will use the new voice plugin. The total time to bug-free code will be averaged across the 2 arms to see if the voice input takes less time. To help us understand the voice technology is like, we will provide a structured interview to the 3 coders in the intervention arm. This experiment will deliver 4 main outcomes. Firstly, a prototype voice plugin for an integrated development environment. Secondly, a practical, quantifiable approach of the performance of the 2 technologies, with the primary measurables being speed and the accuracy of coding. Thirdly, a qualitative analysis of the new technology will be performed on a structured interview of the 3 coders in the control arm. Fourth and finally, we'll provide some conclusion on the feasibility of constructing voice input coding in terms of technical practicality, and of course importantly on whether the technology has or could improve the performance of software coders. Research revolves around asking the right question, one that is answerable and whose answers can make a practical improvement in the world around us. These answers constitute the new knowledge gained from the research. The new knowledge which this experiment will deliver includes a carefully constructed analysis of the comparative performance of voice input versus traditional input in an integrated development environment. In addition, a methodology will be devised to create approaches and measurements which can be replicated to independently assess the same or similar questions.